So let's go ahead and make sure my mic's on. Okay, so let's go ahead and go through the learning objectives for today. So given the genetic makeup of a diploid cell, I want you to be able to describe the genotypes of all the different gametes that we can make. So if I give you the genotype is big A, little a, big B, big C, you should be able to tell me that there's actually only two genotype options. So big A, big B, big C, or little a, big B, big C. Now, if I give you a lot of different options, what I'll probably end up doing is instead of making you list all of the options, I'll probably be like, can you make little a, big B, little c? And your answer should be no, because you only have the big C allele to give from this parent, okay? The next thing is you should be able to design a cross to determine which form of a trait is dominant. So if you're designing a cross, you're going to need to start with pure breeding species. Is the easiest way to do this, or pure breeding lines, I should say, not species, because a lot of times they won't breed. But pure breeding lines can do this, or any other way that you can get a heterozygote. So a heterozygote is going to show dominance, okay? So any way that you can get a heterozygote, that will show dominance, okay? You can actually do this in other ways, other than pure breeding lines. Maybe you have two unknowns that you're wanting to cross together. The thing that's going to be seen in the offspring is going to be the one that's going to be dominant, okay? As long as the traits are different, the two different parents, okay? You might end up, though, at first with a 50-50 ratio and then have to do additional studies. Okay, the next thing is to be able to use a Punnett square to predict the results of crosses, including the genotypes and phenotypes, and the proportions of those genotypes and phenotypes. Now, the genotypes, you don't necessarily need to do the whole 16, but you should be able to do this for one gene or simple two genes. So when I say simple two genes, it would be like little s, big T, little by little s, little t. You should be able to tell me something like that, right? Or where I have like big S's on the other one or something like that, okay? So I'm not going to make you do it for the whole dihybrid, but you might need to for some other potential options, okay? And then those phenotypes too, okay? And then the last thing is to relate the information held on homologous chromosomes to the inheritance of alleles. So only one allele, so one of those two that are held on the homologous chromosomes, will be inherited, right? So gametes, remember, are haploid, right? So each parent gives one copy, right? So here in this one parent gave one copy, right? So one parent gives one copy. You're never going to see big R here, right? Don't let me see two of the same, okay? You're never going to see big R, little R here, nothing like that at all, okay? So just make sure that you guys are remembering that in your gametes, you're always going to have them be haploids, so you're never going to have homologous chromosomes in them, but you do need to have all of the genes that you have. So you need to have both, in this case, the round, or the shape size, and the color as well, okay? So always just remember that. Also, make sure that you're kind of connecting this to sections 1 and 2, where we're going through meiosis and making those different things. So you should be able to make the gametes both this way, that's kind of like a cheat math way, as well as going all the way through meiosis. Okay? All right, so that is it. And I will be hopping back on Friday, or again, to talk a little bit about your guys' project and to show your key for the exam as well, okay? I hope you all have a great day, and I will see you all later. Bye.